Welcome. This will be a quick review of right triangle trigonometry, and we're going to also look at how this kind of relates back to some of the stuff we've done with the unit circle. So if you remember back to your days in geometry, you spent a lot of time talking about triangles. And in that discussion, you always looked at, in right triangles, three sides that we found were important. And those three sides, excuse me, were the hypotenuse, the opposite side, and the adjacent side. Now, those three sides all related back to a specific angle. So looking at a right triangle, the first thing that's probably the easiest to identify is our hypotenuse, because that's the side that's across from the right angle. Okay, and it's also your longest side. The next side that was pretty easy to identify was what we called the opposite side. And that opposite side was the side that was across from or opposite of the angle that was identified. And then that left our third side, which would be our adjacent side. And we call it the adjacent side because it's adjacent to the angle that's been identified. And then we can see, in our ratios, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. I'm just highlighting some things here for you just to make it a little bit easier to identify in our triangle. So we have sine is opposite over hypotenuse. Cosecant, we've talked about, is the reciprocal of sine. So that means we just flip this fraction and make it hypotenuse over opposite. Cosine is adjacent over hypotenuse. And then we flip it to get secant, hypotenuse over adjacent. Tangent is opposite over adjacent. Flip it to get adjacent over opposite. Now, if you remember back in your days in geometry, one of the things that you kind of talked about, or a little mnemonic device that you used, was what we called Sohcahtoa. And that helped you identify, if you have two sides in a triangle, which one of your trig functions would be best to use in that scenario. All right, so now we're going to use that information to identify the 6 trig functions, and we're going to write the ratios. And to do that, the first thing I'm going to do is identify my hypotenuse, my opposite side, and my adjacent side. Okay, now that I have those 3 identified, I know that sine is the opposite side over the hypotenuse. It's OH. I know some of you just did IO. The sine is opposite over hypotenuse, so it's going to be 12 over, well, I don't know what the hypotenuse is. So I run into a little roadblock here. Now, how are we going to figure that out? Well, we have a little hint up in our problem. It says, remember the Pythagorean theorem? So we're going to have to use the Pythagorean theorem here. So that's what I'm going to do. I'm going to take what I know, and I'm going to call the hypotenuse h, just to make it a little bit easier to use here. We'll just call this h for right now. So I know that the Pythagorean theorem says that a squared plus b squared equals c squared. C is always your hypotenuse. So I have something equals h squared. It'll be 12 squared plus 5 squared equals h squared. Now we just have to actually solve that. So that's going to be 144 plus 25 equals h squared. And then continue to solve this, so I get 169 equals h squared, and then take the square root of both sides, and I get 13 equals h. So now I know what h is. H is 13. So if I go back to what I was doing just a moment ago, I want to write the ratio for sine. That's the opposite over the hypotenuse. So I have opposite side already. I just need to write over hypotenuse. Next up, cosine. So cosine is the adjacent side over the hypotenuse. So that's going to be 5 over 13. Tangent is our opposite over adjacent. So that's going to be 12 over 5. And we've got our first 3 trig ratios written. Now what's left is to write the reciprocal functions. Now these are just taking what we've already written and doing the reciprocal. So cosecant is just the flip of sine. So we take the reciprocal of sine and we get 13 over 12. We take the reciprocal of secant, the reciprocal of cosine to get secant, and we have 13 over 5. And then we take the reciprocal of tangent to get cotangent. So that's going to be 5 over 12. All right, so if I ask you to write the the trig ratios, this is what I'm asking you to do. So next up, we're going to be given a trig ratio, and you're going to be asked to find the remaining 5 ratios. So let's start with sine of theta equals radical 2 over 2. Now, if you remember your unit circle, you might not even need to go through what I'm about to go through because you can probably rattle off the rest of these relationships. But what I'm going to do is I'm going to write down all 6 trig ratios, and then we're going to talk about how to find each one. So what I know is that sine is radical 2 over 2. Now here's the thing. We know that sine is the opposite side over the hypotenuse. So what I know is that radical 2 represents the opposite side, and 2 represents our hypotenuse. Well, what that does is it gives me a way to visualize this with a right triangle. So that's the next thing I'm going to do. I'm going to draw a right triangle, and it does not matter what this right triangle looks like. Okay, we're just using it as a guide. I'm going to identify one of those angles as theta. Now, what I'm going to do is write down that my hypotenuse is 2. My opposite side will be radical 2. And then my adjacent side, which I don't know yet, we'll just call A for now. All right. So there are some of these that I can go ahead and figure out pretty quickly. So let's start with cosecant. So cosecant is just a flip of sine. So if I take sine and do the reciprocal of it, I'm going to get 2 over radical 2. Now that's pretty good, but we know we don't like to have a radical in the denominator. So we're going to multiply by radical 2 over radical 2, which is going to give me 2 radical 2 over 2. And then lastly, I can go ahead and cancel out any giant ones. So cosecant is just radical 2. So this is our final answer for cosecant. All right, next up. To find anything else in this triangle, I need to know what the adjacent side is, right? I can't find cosine without adjacent, which means I can't find secant. And I can't find tangent without adjacent, which means I can't find cotangent. So I'm going to use Pythagorean Theorem once again to solve for A. So what I know is that A squared plus radical 2 squared is going to be equal to my hypotenuse squared, which is just 2. So I have A squared plus radical 2 squared, which is just 2, equals 4. Okay, and then I subtract 2 from both sides, so I get A squared equals 2. And then when I take the square root of both sides, I get A equals the square root of 2. So now I know my adjacent side. Okay, now at this point, I can go ahead and find all of the missing pieces here. So cosine, I know, is going to be the adjacent side, which is radical 2, over the hypotenuse, which is 2. So I just found cosine. Now here's something that's interesting, because if I want to find secant, that means I have to do the reciprocal of radical 2 over 2. Didn't I just do that right here? So I already know what that's going to end up being, and it's just going to end up being radical 2 again. So now I've got 4 of them. Next, let's find the tangent. So tangent is your opposite side, which is radical 2, over your adjacent side, which is also radical 2. And anything divided by itself is just going to be 1. Now, what's interesting about this is that if you find cotangent, you can either do the adjacent side over the opposite side, or you can do the reciprocal of tangent. And I could do the reciprocal of tangent here or here. No matter how I do it, I'm still going to end up with just 1. So I've got all 6 of my trig ratios. Next up, let's try tangent of theta equals square root of 3. So once again, I'm going to write all 6 of my ratios down, and then we'll fill in what we know. What you're going to notice is that I initially write tangent not just as square root of 3, but I write it as square root of 3 over 1. And I do that because what I want to be able to do is identify what pieces of my right triangle I actually have. So square root of 3 is going to represent our opposite side, and 1 is going to represent our adjacent side. So now what I can do is I can draw a right triangle, and I can label the pieces that I have. Okay, so if I draw my right triangle, once again, it does not matter how this triangle looks. And I labeled theta in a different place this time. Doesn't matter. I'm going to label my hypotenuse, which I don't know. Just going to call it h. I have my opposite side as square root of 3, and I have my adjacent side as 1. Now, based on our knowledge from the previous example, we're probably going to need to find h. So I'm going to set up the Pythagorean theorem and solve for h. Why don't you do that? Pause the video, come back and check your answer. So hopefully you got h equals 2. All right. Next up, we're going to start filling in what we know and what we can find. So let's start with cotangent because it's the reciprocal of tangent. We didn't even really need the triangle to find this. For cotangent, I'm going to do the reciprocal, so I'm just going to do 1 over square root of 3. And once again, we're back in that situation where we don't like having a radical in the denominator, so I'm going to multiply both top and bottom by radical 3. And what that gives me is radical 3 over 3. So now I have cotangent. I have both tangent and cotangent. So tangent is radical 3 over 1. Cotangent is radical 3 over 3. All right, next up, let's work on sine. So sine is going to be the opposite side, which is radical 3, over the hypotenuse, which is 2. And what's nice about that is there's not really a whole lot I need to do there. I'm actually done. So I've got sine. Cosecant is going to be the reciprocal of that. So cosecant is the reciprocal of sine. I'm going to take 2 and divide by square root of 3. Once again, we're back in that same kind of situation. Multiply by square root of 3 over square root of 3. And what I end up with is 2 over square root of 3. Whoops, no I don't. I end up with 2 square root of 3 over 3. So now we have cosecant and sine. Last up is cosine and secant. So cosine is going to be the adjacent side, which is 1, over the hypotenuse, which is 2. And that's it. Can't really do much else with that. So we've got cosine. And then finally, secant is just going to be the reciprocal of cosine. So 2 over 1, which I could just write as 2. So now I have cosine and secant. All right, now you try one. So go ahead and pause the video for a few minutes and fill in all 6 of the trig ratios given this information. Okay, so if you need to pause the video again to check your answers, go ahead and do so. You can see how I solved for the adjacent side by using Pythagorean theorem, and then just simply filled in each of the ratios. Let's just take a couple of minutes to remember our special right triangles and their patterns. We had 2 special right triangles from geometry. One was a 45-45-90 triangle, and the other was a 30-60-90 triangle. And what I have here is just a visual representation of how those triangles were created and the relationship between the legs and hypotenuse in those triangles. So looking at a 45-45-90 triangle, the thing that should stick out the most is that the legs are congruent. And then whatever the leg is, you multiply it by radical 2 to get the hypotenuse. So if the leg is 4, we multiply it by radical 2, and we'd have a hypotenuse of 4 radical 2. In a 30-60-90 triangle, you have the hypotenuse is 2 times the shorter of the 2 legs. And then the shorter leg multiplied by radical 3 will give you the longer leg. And we know the shorter leg is across from 30 and the longer leg is across from 60. Okay, so let's go ahead and look at a couple of examples here. So first of all, in our triangle here on the left, we notice that there's a 45 and a 90-degree angle, which means this is also going to be 45 degrees. What that tells us is that the 2 legs of the right triangle are going to be congruent. So right off the bat, I know that y is going to be 3 radical 2. Now where it gets to be a little interesting is the fact that our hypotenuse is unknown. But what we know about our 45-45-90 triangles is that if we multiply the leg by radical 2, we get the hypotenuse. So really, to figure out x this time in this triangle, I'm going to have to take the leg, which is 3 radical 2, and multiply it by radical 2. Okay? And then it's a simple matter of doing some multiplication. So guys, when you see a radical 2 times a radical 2, when you see a square root of something times itself, you're really squaring that thing. So it's the same thing as saying 3 times the square root of 2 squared. Now we know that square root of 2 squared is just 3, so that's really, or sorry, the square root of 2 squared is just 2, so it's really just saying 3 times 2. So what we get is that the hypotenuse is just 6. Okay, next triangle is a 30, 60, 90 triangle. Now, in this 30, 60, 90 triangle, and I'm going to go ahead and label the angles as well. Now, what we have to ask ourselves is how are we going to find the missing pieces? So we've got to look for the relationship between the missing pieces, all right? If I highlight things in these two triangles that correspond to each other, so that 10 corresponds to the side across from 60. My y is my shorter leg because it's across from 30, and my x is my hypotenuse. So what I know is that in order to get this pink side, I had to take the blue side and multiply it by radical 3. So what if I set up an equation that says just that? If I take that blue side, which is y, and I multiply it by radical 3, I have to get the pink side, which is 10. All right, well then to solve for y, I'm going to have to divide both sides by radical 3. Now, once again, we don't love having a radical in the denominator, so I'm going to go ahead and multiply by radical 3 over radical 3. And what I get is that my shorter leg is just 10 radical 3 over 3. So now I know what y is. Now x, let's again match up things that we know. I know if I take the blue side and multiply it by 2, I get the green side. So I have to take this blue side, multiply it by 2 to get x. So really what I'm saying is to get x, I've got to take 10 radical 3 over 3 and multiply it by 2 over 1. And I write it as a fraction because you guys know me, I like to have all fractions. So really, we're saying 2 times 10 radical 3 all over 3, and we can multiply 2 and 10 together since they're outside of the radical. We get 20 radical 3 over 3. So now this is 20 radical 3 over 3. Okay, last one. This is another 30, 60, 90 triangle, so let me label the 30-degree angle here. And once again, I'm going to highlight them so they match up with my kind of cheat triangle. So across from 30 degrees is my shorter side. That's going to be 4. Across from 60 degrees is n. That matches up with the x radical 3 in my cheat picture. And then the hypotenuse is my green side. So if I look at my relationships here, if I take x and I multiply it by 2, blue times 2 gives me green. So I need to multiply 4 by 2 to get the green. So in order to get m, I have to do 4 times 2. Well, that just gives me 8. All right, that was easy enough. Now we look at the relationship between blue and pink. To get to the pink, we have to take the blue and multiply it by radical 3. So in my picture, in order to get pink, I have to take blue and multiply it by radical 3. And that's really all there is to it. We don't have to do anything to simplify that because there's no radicals in the denominator. All right, well done. Make sure you fill in the form and leave any questions if you have them, and I'll see you in class.